Okay, can we start the class today? Okay, so let us recall this topic. Okay, non-homogeneous recurrence relation is of this particular form where A consists of two. One is homogeneous linear recurrence equation, another one is the function of n here like that. The solution also we will have like this. For homogeneous equations, we have the solution like this: a n to the power h plus a n to the power p for the function of n. That's what we discussed in the last class. Example for non-homogeneous linear recurrence relations are given like this. Are they? Yes, because an consists of two terms, one based on its previous terms, another based on n terms. Okay. Similarly here. Now let us take this problem. Find all solution of the recurrence relation. An equals 3an minus 1 plus 2n. Okay. So this is what? Homogeneous or non-homogeneous? Of course, this is a linear equation, recursion equation. Okay. But non-homogeneous or homogeneous. That's what we have discussed here. Once we differentiate that, then only we can solve the problem. Am I correct? If it is a homogeneous problem, then only one solution will come. If it is a non-homogeneous, two solutions we have to get, one for this and another for this. Okay, right. Now what is the initial value given as a1 equals 3? That is, when n takes 1, then the term is 3. When n takes 1, the first term is 3. That is initial value given to us. I think that this initial value is enough to solve this non-homogeneous recurrence relations. Right. We know that the solution of linear non-homogeneous recurrence relation, already I was discussing in the last class about an equals an power h plus an power p for non-homogeneous linear recurrence relations. This is the solution style, we can say, a solution format. Okay, I am taking that as equation number 1 because this may be useful in the future, because we may be substitute after finding out this and this in this equation. Therefore, it is better to identify this as equation number 1. Here, given the associated linear homogeneous equation, first we are discussing about the associated linear homogeneous recurrence relations. Afterwards we'll take this one. So here the first one, an equals 3 into an minus 1 is the associated linear homogeneous recurrence equations. Am I correct? This is not included 2n. Okay, right. Now let us find out the characteristic equation of this particular homogeneous linear equation. So an equals 3 into an minus 1. You look at that. An equals 3, an minus 1. Okay, you bring this side, you'll have an minus 3 an minus 1 equals 0. Am I correct? Yes. So rearranging that, you will get a linear equation like this, or quadratic equation like this: an minus 1. Okay, so what is a characteristic equation of this particular homogeneous recurrence relations? This is if you factorize this, or if you change this into a characteristic equation, you will get this: r square minus 3r, but there is no constant there, therefore constant term will not come there. So r square minus 3r equals 0 is a characteristic equation of this homogeneous linear equations. Now let us find the solution, I mean the root of this characteristic equation as we do normally, usually. Okay, so we can write r square minus 3r equals 0. This we can write as r into r minus 3 equals 0. It implies that the product of both of them must be 0. R must be equal to 0 and r minus 3 must be equal to 0. That's what the algebra says. So if r equal to 0, r minus 3 equals 0, then two roots we get, r equal to 0 and r equals 3. Okay, right. So since it is a quadratic equation, we have two roots. It is general solution. General solution will be of the form a n of h. H we are taking because it is connected to the associated linear homogeneous recurrence relation. Therefore, in order to connect that, we are writing like this, would be one constant alpha into its root 3 power n plus a beta into the root is 0 power n. You will get alpha into 3 power n. This I am taking as equation number 2. So I have got the solution for the associated linear homogeneous relation. So I got it. So first solution I got. Look at that. I'm going to substitute that here in equation number 1. So remains to find is this. This is what remains to find. The perfect root, perfect solution. That's what I have to find. Now to find the second solution here, what is the second solution here? Is an power p. Now I am taking f of n equals 2n. That's what is given there. That's what is given there. Okay. So if f of n is equal to 2n, then from a differential equation, the solution, general solution would be of the form an power p equals cn plus d. It's a general form of a function of n which is of this particular type. This is I am taking as equation 3. Okay, equation 3 I am taking. Now let us find the c and d here. So given, what is given there, the given recurrence relation is an equals 3an minus 1 plus 2n. Now look at that. The given equation is 3n minus 1 plus 2n. Now cn plus d equals 3 into what is n? What is n? So 3 into an minus 1. So in the place of n minus 1 we are substituting, because an equals cn plus d, that we are substituting here with n minus 1. So we have 3 into c n minus 1 plus d plus this 2n as it is. Now simplify this, and then the coefficient of n, okay, then you simplify at last. What you are getting is that c is equal to minus 1, d equals minus 3 by 2. Okay, so from these two equations you can solve by algebraic method, and you will find that c equals minus 1 and d equals minus 3 by 2. So substituting at this in equation number 3. What is 3? 3 is the perfect square solution. So c value substitute here, d value substitute here, and you will get the solution as a and p is equal to minus n minus 3 by 2. So substituting these 2 and 4 in equation number 1, because equation number 1 is the solution for us. It's a summation of associative homogeneous function and this perfect square. Substitute that and simplify. At last you will get alpha value. You substitute this, will get an equals minus n minus 3 by 2 plus 11 by 6 3 power n. Okay, and this is the solution set for this particular non-homogeneous recurrence relations. Okay, look at that. It consists of two terms. One is associated with homogeneous function, another one is associated with the perfect solution.